Hi Mickey, Ornella, Josh and John. This is that video I wanted to discuss or show you the density, the population density. So it's a bit of a response to your video, Mickey, where you're talking about wanting to attach a population density to each of these hexagons. And this is actually a very simple process. So what I'm going to do is I've isolated a couple layers. So it's a new project, and I've just got the most recent households layer that you've sent me, which looks like that. Okay, so these are just all those households as little black dots, and I've got the dead space as well. And maybe I should actually just change this color because it's sort of conflicting with the color that I've chosen for the households at the moment. Maybe like a deep dark purple will do the job. Okay, that's fine for now, and we'll have a look at this dead space area later. So the areas that are not going to be used in the density, or possibly not used in the population density calculation. Okay, so what we've got is we've got two layers, our households and then our service areas resource potential layer. And if we zoom in, we can see that some areas are more dense than others, and some areas have better resource potential than others. So I guess the ultimate question that we're going to be asking is, does the area, our study area, one of the hexagons, does it have the resource potential to service the water need based on the population density? So what we'll do is we'll calculate the population density for each and every one of the hexagons, and then what we can possibly then do is have a look at the category for that hexagon and determine how many pumps can be or are going to be necessary based on the population density. And I don't know the category yields for each of those pumps. I guess you'll just have to fill me in there. For instance, what does a solar pump yield? How many people can it service? Etc. So let's start off by just doing a population density. So that's quite easy. So I'm just going to zoom to the full extent here. Okay, and it's quite easy. There's a little tool in your vector menu, and it's called count points in a polygon. Let's have a look. Analysis. Count points in a polygon. So that's the one we're going to use. So we select that option, and now what we're going to do is we're going to basically assign the number of points that intersect with a polygon to that polygon. So the polygon layer we're using is the service area polygon, and there is only one point file in this project, and that's the households. So that's fine. We're not going to weight it. We're just going to count the absolute number of points, and it's going to, what it does is it basically creates a new field in the polygon layer, and in that field it puts a number with the number of points that intersect that particular polygon, and that is the field name. So we're going to leave it as number points or num points, and then you can create a temporary layer or you can create a new layer. So for this example, I'm just going to create a new layer. So we're not going to end up corrupting our original service areas shapefile. So we'll just create a new one, and we'll save it to file. And I've created a folder on my desktop, and I've just called it temporary. And what should I call it? I'm just going to go household count. Okay, and I'm going to make it a shapefile. Okay, you can call this whatever you want. But anyway, I'm just showing you how to do this so you can know for future reference. Okay, so there's my new layer, and I'm just going to click run and wait for that to process. Now, there are thousands of households that you guys have been so diligently capturing, so this might take a while. So I'm just going to pause the video and then come back once that has been fully processed. Okay, so when that's finally done, you can move on and start doing some more queries with the new layer that's produced. Yeah, so don't panic. That kind of took my computer about 15 minutes to do. I started off at about 10:56, and it finished at 10 past 11. So look, that might take a while, but if you have the time, maybe just set it out to do it over lunch or something, and just let it run the process, and don't do anything else on the machine until that is completed. Okay, so now that is done. So now what it says here is it should have a new field called what is it called? Num count, I think it was, and then there's going to be a value in there for the number of points inside each of those polygons. So let's have a look inside that new layer, and here it is here. So I'm going to right click and open up the attribute table. And it's pulled through all of the fields from the original resource potential grid, and then it's added a new field here. And I'm just looking at these values, meter squared and kilometer squared. I think that does exist in the original as well. Have I hidden a whole bunch of layers here? I just want to have a look. Organized columns, yeah, okay. So those, what I've done here is I just wanted to see that it hadn't added extra columns. So I just right click on this gray bar up here and I say organize columns, and I can see that the ones that are ticked are the ones that are viewable. The ones that aren't ticked are not viewable. So for instance, if I turn that kilometer squared one back on and said OK, then that one would now be viewable. Okay, so that was me just checking to see that it hadn't added any extra columns. So it hasn't. Okay, but since it's a new column, it hasn't been, none of these columns have been turned off. So since it's a new layer in our project, nothing's been turned off. So I'm just going to turn off all the columns that I'm not really interested in for now. So I'm going to right click. Whoops, I just need to move to the side here. Well, I think I can actually right click anyway on one of these fields. So I'll right click, organize columns. So I'm going to deselect all of them. I want to see kilometer squared. I want to see the resource. Maybe the category as well for now. Link ID, let's turn that one on. And the other ones, okay, the new ones are num points. Okay, so we can say OK. And so it's just turned all those other ones off. They haven't been deleted, they've just been turned off. Right. So now what we want to do is calculate the number of people per cell, per hexagon cell. And these are household counts. And I think in our discussions we discussed an average of 5 persons per household. So let's go and create a new field. So I'm going to start editing. I'll use the calculator. And I'm going to call this population. And it's going to be a whole number. And all it is going to be the households multiplied by that number. So let's go and find the households, which is essentially the number of points per polygon, times by, I think it was 5. So times by 5. So if there are 5 persons per household, then the new column will show the total population for the number of households in that cell. We'll say OK. And there we go. So now we've got population. So now that we've got population and we've got area, we can calculate the population density. So we're going to run that again. And you could have skipped this step with just adding in some brackets in an equation here. For instance, you could have just gone number of points. So if you wanted a population density, you could have just gone, what is it? So it's going to be number of people divided by the total area to give you a population density. So you could have gone, so number of points times by 5 divided by kilometers squared. So you could have skipped that step, but I enjoy having this extra column here. It just shows me the population for that cell. So let's do that now. So we're going to say people, population at least, divided by the total area in kilometers squared. Okay, we want to give the output field a name of density. Density, and it can be a whole, actually we can make it a decimal number. And actually no, let's make it a whole number. This is going to be up to you whether you want a whole number or a fraction or decimal number. And we can say OK. Right, so now what is this telling us? There are 215 people per kilometer. Okay, yeah, so that's per kilometer squared. Okay, so that is how we calculate density. So now what we can do is we can just say stop editing, save, and we can go and color up on that population density. So what we'll do is we'll just go right click on count layer. I think we called this actually something else, so let's just rename that quickly. I think it was household. What did I call it? Actually, let me just quickly have a look in on the desktop folder that I created, and I called it household count. Okay, so I'm just calling it household count. Okay, household count. Right, so now let's look at having a look at that symbology. So we are going to use the graduated symbol option. The column we want to use is density. And now you can choose the mode that you want to choose. You can choose anything here: pretty break, standard deviation, quantile. If we go equal interval, and then we can set the number of classes to 10, for instance, and that's what it's going to look like. So now this is up to you how you want this to display. But if we just say, I'm going to drag this off to the side and just click apply, and then turn off my actual households. I want to turn off my households. There we go. So there we can see the density of the darker areas versus the higher density of the dark red areas versus the lower density light areas. And we can always just zoom in to double check that this is in fact telling the story that it should be telling. And then you can see, obviously, there's a whole lot more households within that hexagon cell compared to this one. Although this category is, I mean, there's still plenty here. So you might want to come in here and tweak the actual category. So for instance, you can go in here, open up the symbology for a layer, and you can double click in the value section and change that to 100, for instance, and you click OK, and then you'll see it changes that to 100, and then it changes the starting value of the next category to 100 as well. You could maybe make that 250, and you can continue doing that depending on how you want it to display. I'm just kind of making this up as I go, etc. And you'll see it does get tweaked as you go down. So if we applied that, you'll see this will changes slightly, and we zoom to the full extent. Okay, and we can see the density in a shaded color. Now you can also, if we have a look at this, you can choose a separate number of classes. You can make 20 classes. You can only make it 5. You can use a different color ramp. Really, you can do anything here. So this is all up to you about how you want this to display. Spectral. If I can right-click on that and flip it around. So invert color ramp. So now we've got low density areas are like a blue color. High density areas are like a red color. If we apply that, it looks like that. But that doesn't display very well because of the categories chosen. So we could just go in and do some further editing, like I was doing just now, where you just double-click under the values section and change the upper value to a slightly lower number, and you can run through and do that for the rest of them as well. Just make that one 2000, and then this one 25, and that one can stay as is. We apply. It didn't have much of an impact on how it was coloring up, so you can go and tweak them further if you want to. But anyway, that's just a visual representation of the population density as we've worked it out. Right, so then what you can do, and this is where your knowledge on the various categories and what type of pumps are going to be used in the resource potential categories. Category 1, let's say it's one of your solar pumps and it services a, I don't know what, like 2,000 people. Each pump can service 2,000 people or 2,500 people. What you could then do is divide your population by the actual pump category. You can actually create a new column here. So for instance, you could do this and just say, what would it be? The number of people that the pump can service. So I don't know, number of people serviced, something like that. Okay, and then what you would do is per category, let's just make them all for instance for now, we'll just make them all 2,500. You say okay, you get a new column called number serviced, and then what you can do is create another column called number of pumps. So you'll go number of pumps required, let's say, number of pumps required, and then all you do then is say number of people. Okay, so we're not using the density now, it's the total population. So we'll go to total population divided by the actual number serviced by that pump. So this will be different depending on what category it is. So let's go and find number service. Yeah, okay, here we go. And then you can see that for this population, okay, that's a whole number, so maybe we should have made that a decimal number. So or round up. You can round up if necessary, because you don't want to underestimate. You may need to have an extra pump there, so you can round up. And in this instance, if you round it up, you would need 2 pumps for that particular cell based on that category, if the number of people that pump could service was 2,500. So you would change these depending on the category, whether it's it's a hand pump, or if it's a solar pump, etc. I think I've explained how that would work, and I hope you get what I mean by that. So that's how you can calculate the number of pumps that would be needed for each of those cells, based on the resource potential and the population based on your household count. Okay, then lastly, and I didn't really want to start with this because I didn't want to make it too confusing, what you can do, initially, one of the things you mentioned is that you were worried that, for instance, if we go into an area where there's dead space, like over here, and we turn on the households, let's maybe make these dots a little bigger so we can see what they look like at this scale. So I'm just going to make them, let's make them 1, actually maybe even make them 2 so we can see them properly. And maybe make that a lighter color so we can see the purple and the black are clashing a bit. So if we say like a lighter purple like that. Okay, so in this instance, and what I'll do is I'll just duplicate this layer as well. I'm going to remove all the symbology for it. So I just want to go single symbol, and I'll make it no brush and make this 0.4, 0.25. That should work. I just want to see the boundary of the hexagon. So I'm going to turn that on and stick it right on top. Okay, so this portion of the cell doesn't have any people living in it. And based on this boundary, you can see that there are some households living on the wrong side of the boundary. So if you wanted to calculate the serviceable area, you would need to exclude anything that was in dead space. And you can do that by doing a union. So let's try that now. So we've got dead space here as our category, and we're going to use a union option. So I think it's, where is it? Is that under geometry tools? I'm looking for union. Oh, it's geoprocessing, under union. Okay, so we're going to union dead space. I'm going to start off with the actual surface area potential. So we're going to surface area potential and dead space. And in this example, I'm just going to create a temporary layer. I'm going to run that. Now it's quite a bit quicker than the other process we ran a bit earlier. So I'll just keep the video running and close that. And now, if we open up that attribute table for that new layer, we should have a dead column that says dead. Okay, so where there's null, there's no intersection, and then for any other value that says dead space, that's where there is an intersection. So what you can do now is you can run that exact same query. I'm going to zoom out slightly. Just turn on this dead space. Okay, so there we go. So we can see all the dead space is purple, and with the new union file, it is included. So if I went ahead and colored up on that column, so let's categorize on dead, classify. So if it's pink, then it's dead space. If it's green, it's usable, or there is a demand. There is a water demand, let's say. So now what we can do is we can go back to the beginning of this video and start that whole process, except this time we're only going to use the areas that have a demand. So we're going to exclude everything that doesn't have a demand. Okay, but before we do that, we're going to need to update the area of each of these cells. So what we could do, let's think about this, is I'm going to actually remove everything that is categorized as dead space. And we'll start editing. I want to use my little selection tool, and I want to select by a little equation There it is there. Select by expression. I want to go dead. Okay, the column is called dead, equal to, and then just use unique, dead space. Select features, close. Okay, so we're inside an editing session. I want to delete all of those. Yes. Okay, those are history. I'm going to stop editing, say yes. I'm going to turn off these other layers. So now we can just zoom to the new union shapefile, and I'm going to turn that off as well. And you can see that the white areas have been excluded from the layer now, so they've all disappeared. So now what we'll do is we just need to update the area. So we'll go to, is it geometry tools? And I think it's add geometry attributes. So union, and we can use the layer CRS, which is universal transverse Mercator. I think it's 35 south for you guys. So we'll create another temporary layer. Close that. So now that is my new layer. And if I open up the attribute table, we should have updated area columns. So we just need to divide that by 10,000 to get kilometers squared. So most of them are probably still going to stay 15, but the ones that have been intersected and deleted are going to change down. So let's do that quickly now. I'm going to use this calculator. I'm going to update the existing one, kilometers squared, and it is area divided by 1 million to get kilometers squared. Okay, you'll see there's the preview of the answer, and it looks correct, 15.6, 15.6. Okay, and now if we sort, you'll see there's a whole bunch that are quite a lot lower. So if we have a look at this one and zoom to it, let's zoom to selected, you can see that that one now, all being treated as one area, can be now calculated specifically for the households that intersect that area. So if we did this before we started the video, and then let's just save that, and now we did the calculate number of points in a polygon and then density and population, we would then come out with a value that excludes everything that is not dead space. Okay, does that make sense? If not, give me a shout. I'll try and explain that better. But that is how you would calculate density, and then also the serviceable area need, number of people living in an area, and then with regards to how you treat these categories and the type of pump and number of people serviced, you can take that value and divide it by the actual people in that area to come up with a number of pumps needed. Alright, great. Let me know what you think of that video. If it makes sense but you don't think it's clear enough, let me know, and I can always try and clarify. But those are my thoughts and my methodology for how I do that. Yeah, good luck with that. Give me a shout if you have any questions. Cheers.